Welcome back to Ranoak, my N-Gauge layout. This is the 7th and final video in the series. The 6 previous ones being the layout, me and my trains, animated scenery, how it works, the running schedule and scenery. The subject of this video is the lighting required to bring the layout to life after dark. So I'll start with buildings, then street and external lighting. But before we delve into the lighting of the scenery, etc., it is perhaps worth looking at the difference display lighting can make to the layout. I have added an array of LED strip lights, and the control panel would not look the same without all the indicator lights using radio spares, sub-miniature LEDs. We will then explore the provision of coach lighting, followed by signals and the installation of running lights for those engines that did not have them fitted at the time of purchase. Apart from the street lights, the type of LEDs that I have used are LED strips, standard LEDs and very small LEDs known as SMDs. A day and night drone sequence illustrates the whole layout from Ranoak town to the main station, followed by a view of the industrial area. This in turn leads to the engine sheds and scrapyard. Moving on, we see Upper Ranoak Station and the farm, and then the Falkirk Wheel, and finally Upper Ranoak Village. Buildings incorporate standard LEDs which are built in at the time of assembly. So some examples are the parish church of Upper Ranoak and the village, a country pub, the farm and Upper Ranoak station, the bus garage, boiler house and signal box, a row of terraced houses, obviously before the energy crisis, Ranoak town station and the high street. There is a barn where the light should have been off or the door closed. One word of warning, the card used for the buildings is fairly thin and therefore some of the roofs and walls seem to glow. I should have painted in the insides black perhaps. There are 7 styles of street lights, starting with the Ranoak Town High Street and back streets, Ranoak Town Station platform lights, the station approach road and the bridge over the station. There are different lights for Upper Ranoak platforms and for the village itself. I have used M6T high mast floodlights with SMD LEDs to illuminate the car park and industrial area, with lower floodlights for the bus garage, engine sheds, scrapyard and canal basin. More pre-wired SMD LEDs are used for the external lights for the farmyard, on the cinema and to illuminate the Falkirk Wheel and approach canal. As in real life, wind generators seem to breed, so when mine failed, a gear disintegrated, I decided to replace it and incorporate the broken one as a static model. The blades had to be feathered so that they did not turn in the wind, but both have flashing LED aircraft warning lights. Attention to detail is why this layout is called Ranoak. While working on this video, I managed to drop the power supply for the LED lights. It was a 6-circuit Hamilton Morgan transformer, so pretty heavy, and all the wires broke off. So in the industry parlance, we had a power outage. I decided to ditch the transformer and use the one already supplying the tungsten lamps. This proved quite easy, and power was returned to all the properties. In the reconnecting process, I connected the Falkirk Wheel floodlights to a circuit without a resistor, which blew all 10 of the SMD LEDs. The replacement of these LEDs was a lengthy process, as they had all been built in when the model was made. However, the job has been done, and I took the opportunity of trying to improve the lighting by not setting the new LEDs into the tubes or the arches, but on the surface, with the brightest side showing. I think that there has been an improvement. Moving on to coach lighting, a project that has had its beginnings, middle and back to the beginning. I started by fitting LED strips, a reed switch and a 3-volt battery. They worked fine, but battery replacement became a nuisance, so I investigated picking up the power from the track. This meant that additional components would be required, namely a rectifier to convert the DCC track supply to DC, a capacitor to deal with the flicker caused by poor track contact, and resistors to reduce the power to the LEDs. We now come to the tricky bit: how to pick up the power from the track. Most articles on powered coach lighting focused on the pickups from the wheel axles with proprietary springs or pickup brushes. As all my axles are insulated, it is necessary to electrically connect one wheel to the axle. Two methods are suggested: drilling through the insulation ring and inserting a piece of wire, or removing the insulating ring and refitting it with a piece of fine wire which connects the wheel to the axle. And although I succeeded in making the axle live, the purpose-made pickup springs or my own wiring caused unacceptable resistance to movement. The time spent and the damage to several wheel sets, not to mention the resistance to movement, made it a non-starter. However, I did try again when I saw an idea of picking up the power from the wheels themselves, which was proving successful. Minimal resistance to movement and a live axle is not required. The pickups, CCN10s, are supplied by Tram Fabric. I further worked on reducing the friction from the contacts by making them pick up from the back of the wheels and by producing a wipe contact with the coach to reduce the turning resistance to the bogie caused by the wires. Initially they seemed to work well, but after a fair bit of testing it became obvious that poor contact with the track, a build-up of dirt on the wheels, defeated the whole object. At this point I abandoned ship and reverted to the original battery versions, which are operated by passing a small magnet over the latching reed switch. One further problem that was easily solved, however: by lighting the inside of the coaches, they have to have seats and people. One thing always leads to another. Both signals and the loco running lights utilize the SMD LEDs. The photograph with the match head illustrates their size, and to direct the light and reduce spillage, I install them in a copper tube. Here are some examples of the signals in operation. The loco running lights are all installed on a similar basis as the Class 37 shown. All of the LEDs, which have been connected to the appropriate decoder terminals, are in short tubes fitted into the engine body. Before I go, I found a clip taken about the operation of the Ivy House lift bridge, which didn't get into the animated scenery video. It was taken on a rotary canal trip in 1999.
The bridge requires a British Waterways key to operate it, and is often the cause of much frustration to both boaters and motorists when the operator does not read the instructions inside the lid of the operating box carefully enough. The bridge will not lift unless both the road barriers are properly down, and the barriers will not lift unless the bridge is fully down, and the operator cannot remove the key unless the bridge is down and the barriers are up and the lid of the box is closed. Needless to say, we experience no problem at all.
Well, that's all. I hope you've enjoyed the series, and thank you for watching.